we look at SOHCAHTOA in the past, you guys were given just a plain old triangle, correct? And it would just be sitting on a page. All the triangles we are going to look at this year are superimposed on the Cartesian plane. Okay? So if I threw a triangle out here, we're always going to use the central angle. And remember, your hypotenuse never changes. Your hypotenuse is the angle in grade 10 that you get taught that's always across. It's the longest side, and it's always across from 90 degrees. Okay? That's how it always works. That's the hypotenuse. The reason why people stink at trig in grade 10 is they don't realize that opposite and adjacent change depending on what angle you're using. Right? Well, the great thing is once they realize that that happens, it's really easy. So same thing here. Our angle will always be the center angle. So it will always be this one. So here's my 90. So this is going to be my hypotenuse. And if we're using the center angle, is this one adjacent or opposite the one right beside it? Adjacent, because it's beside it. And then this one is opposite. We agree? So SOHCAHTOA works because you have random triangles that are placed anywhere on a page, and they're flipped in any order, any manner, right? For us, we will only look at triangles literally on the Cartesian plane. That's it. So if they're on their Cartesian plane, instead of saying adjacent, what value is this? The what axis? The x. So adjacent and x are actually interchangeable. Okay? And opposite would go with what values? Y. So y and opposite are interchangeable. And the hypotenuse, if you can imagine, these are always going around like this. The hypotenuse is actually interchangeable with r, because it's the radius of the circle. So instead of SOHCAHTOA, we have, instead of opposite over hypotenuse, we have y over r, because y is opposite, r is hypotenuse. Instead of adjacent over hypotenuse, we have x over r, and instead of TOA, we have y over x. Okay? Sometimes it gets taught last year, sometimes it didn't. So I'm going over the whole thing as if it's fresh. Now, I have stupid acronyms to remember them. You're welcome. And you're like, these are dumb, I will never use them. Yeah, you will in about by the end of the day. So, sign, you can do sign your resume. No one signs their resumes, but you will, because that's how you can remember it. Sign your resume. And then for coast, it's cook extra rice. Someone made this up with me about 5 years ago in class. You're welcome. There's probably like 10. You make new ones? No. Yeah. And then tan your Xbox. Because who wants a vitamin D deficiency in their Xbox? You know, you're often playing games in a really dark environment, right? So you need to tan it so that it is not, lacking the vitamin D. Doesn't get scurvy. Lack of vitamin C too. I don't know how I brought that up. It has nothing to do with sun. You're welcome. Yeah. Good work. Yeah. Sign your resume. Cook extra rice. Tan your Xbox. Yep. Yep. All right. Okay. For points on the unit circle, R is 1. Therefore, the primary trig ratios on the unit circle, our sine is y, cos is x, and tan is y over x. That's why the points on the unit circle are cos then sine, Calgary Stampede. Because it would be y over r, but the radius of the unit circle is 1, correct? And this would be x over r, x over r, which is cos, and then y over r, which is sine. But what you can just remember is it's Calgary Stampede. Now, for the fun part. There are secondary trig ratios. The great thing is they're on your formula sheet. Go look for them. They're at the very top right. So, cosecant, this is the best. So cotangent is cos. It's cotangent. It has the word tangent in it. It is the reciprocal of tangent. So how do I know that? Because the formula sheet says it's 1 over tan, correct? Secant is the reciprocal of cos, and cosecant is the reciprocal of sine. So C's and S's don't go together. So secant goes with cos, and cosecant goes with sine. So secant is the reciprocal of cos, and cosecant is the reciprocal of sine. And if you forget, your formula sheet shows it as 1 over sine, correct? Like on the very top right, you guys can see that. So, if cosecant goes with sine, if sine theta is your resume, then cosecant theta is resume your. It flips. If cos is cook extra rice, then secant is rice extra. It flips. And then if it's tan your Xbox, cotan is Xbox your. It flips. Okay? You're all like, that's stupid. Yeah, you're going to memorize it. That's how it's going to go. Now, biggest pet peeve, also biggest you wrong moment, is trig ratios. If you do this, sin equals 7 over 3. First off, that's not possible. Sin equals 3 over 7. It has to be less than 1. Well, sin doesn't equal 3 over 7. You might be like, well, why are you saying sin now instead of sine? Because you say sine when it has a what beside it? A theta or an x or a something. You guys forget this. I get this all the time. Cos equals 4 pi over 3. Or 4 root 3 over 3, let's say. No, cos theta would equal that. You have to have this. And if you're given an angle, where does it go? In this. That's where the angle is. Okay? All right, back to here. So, then you have cast rule. Or some people memorize it as going in the order of like a C, like Crystal, like I said to you. All students take calculus, which is kind of comical because no students in this class are taking calculus. Good enough. So it's super untrue. If you want to memorize it that way, you can. So, all are positive here. All 6 of them. So sine, cosine, cotangent, tangent, cosecant, secant. In 2, sine is positive, and sine's bestie is cosecant. So cosecant would be positive. Because remember, if sine is a half, cosecant is 2 over 1. It just flips, correct? So if sine is positive, cosecant will still be positive. It just flips the fraction. It doesn't change the sign. If tan is positive in quadrant 3, then so is cotan, because it's just tan flipped. And if cos is positive in quadrant 4, then its bestie secant is also. All right? So, here it says, given the following point on the terminal arm of some rotational angle, halt. So let's just draw this first. Okay? I gave you a coordinate, -2, -6. Let's draw it. So, we draw our Cartesian plane. -2, -6. It's here. Okay? Sketch your point. Let's go. Sketch your coordinate. -2, -6. Okay, given the following point on the terminal arm. So it's on the terminal arm. So I'm going to draw a terminal arm. Terminal arms always come out of 0, 0. Thanks, board. Really not happy with me today. -2, -6. Find the exact value for all 6 trig ratios and the rotational angle to the nearest degree. So we'll talk about that in a second. We're going to find all 6 trig ratios of all the questions first, and then we'll come back and do the rotational, so we don't overwhelm you. Okay, if I want 6 trig ratios, I need x, y, and r. We agree? Because that's what's needed for all the trig ratios. So we always draw our triangle towards the x-axis. We will always draw a bow tie triangle. Never an hourglass. We're not making an hourglass, we're making a bow tie. So I know then that x equals what? -2. And I know y equals what? -6. And r, how would I find it? Does anyone remember? We can use grade 10 math. X squared plus y squared equals r squared, or a squared plus b squared equals c squared, right? So we're looking for the hypotenuse. We're looking for the r. So instead of a squared plus b squared equals c squared, in trig we say x squared plus y squared equals r squared. Okay? So we're going to go x squared plus y squared equals r squared. So we get negative 2 squared plus negative 6 squared equals r squared. Then we get 4 plus 36, so 40 equals r squared. And then we physically take the square root with our own arm. When we physically take the square root, what do we have to remember? Plus or minus. Now the catch here is the radius, it's a standard of measurement, right? It's like an actual measurement. So the radius is always positive. So if you're finding r and you forget the plus or minus sign, you're lucking out. Okay? Now 40 is a lovely number. However, it can reduce. And if we can reduce the radical like grade 10, we do reduce the radical. So what perfect squares can we break it into? 4 and 10, someone said, which is true. So we get 4 times 10 equals r squared, or equals r. Okay, guys. 4 times 10 equals r. Then what do I have to do? Take the 4 out, it becomes a 2, so I get 2 root 10. And it's positive because it is r. So guys, I now have x, y, and r. All 6 trig ratios need x, y, and r. So once I have that, I just have to fill them in. Okay? So let's fill in our 6 trig ratios. Our first one is sine. Sine, and what do I have to make sure I put beside it, or is the word sin? Theta. Sign your resume. Some people put sign your Xbox. You don't want to sign it. You won't bring it in. We want to sign your resume. So we're going to get your, which is negative 6, resume, which is 2 root 10. Now what can I do to the 6 and the 2? Take a 2 out and reduce it. So I get negative 3 root 10. Negative 3, sorry, over root 10. And then I'm not allowed to keep my denominators radicals in 30-1. So I have to rationalize it, which I was taught in grade 11. So I multiply by whatever that radical is. And what I do to the bottom, I have to do to the top. And the reason why you multiply by the same radical is root 10 times root 10 is root 100, which is just 10. So whenever you multiply 2 radicals that are the exact same, you get that answer back without the radical. So we get negative 3 root 10 over 10. So that's sine theta. Let's do its bestie, cosecant. So if sine is your resume, cosecant is resume your. It flips. So this one is your resume. This one is resume your. Just helping myself off to the side over here, right? Yeah? So I put my theta in there, and my r is 2 root 10, and my y is negative 6. And then I can take a negative 2 out of each of these, so I'm left with negative 1 over 3, because they'll often put the negative in the top. But guys, I want to show you something. So they can give the answer like that. They could give the answer where the negative is sitting completely in front. Or they could give the answer where it's root 10 over negative 3. Those are all the exact same answer. Which one's better? The one that matches the multiple choice. That's literally the one that's better. Okay, I want you guys to try the other 4. Cos and secant, cotan, and tan, using the trig ratios above. Cos theta is cook extra rice. So we are going to get negative 2 over 2 root 10. The 2's cancel. And we get negative 1 over root 10. And then rationalize. So So it equals negative root 10 over 10. Secant is its bestie. Secant theta. Make sure you have thetas. There's some people who try and get through the entire unit test without using a theta. That is not a good thing. That is a whole lot of lost marks. So secant theta is the flip of that. So rice extra. So we're going to get 2 root 10 over negative 2. The 2's cancel and the negative will come up and it will be negative root 10. Okay. Then we have cotan theta is, well, I'm going to do cotan first. Some people question things. Okay. Tan theta, tan your x box. So this one is your x box. So it's going to be negative 6 over negative 2, which is 3. And cotangent theta is x box your. So it's negative 2 over negative 6, which is a third. Okay? And flip over. Okay, 3 and negative 4. Draw it out. 3, negative 4. We always make a bow tie triangle. So we get x equals 3, y equals negative 4, and r equals something, something. We got to figure out what that something, something is. So we do x squared plus y squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. Square root plus or minus r equals 5. So this is a nice one because there's no rationalizing, right? Yeah? You get 1 minute, do all 6, go. So, we have sine your resume, so negative 4 over 5, which is besties with cosecant. It's just a reciprocal of it, so it's negative 5 over 4. Remember, if sine is negative, cosecant is negative. It's also in quadrant 4. What's the only thing positive here? True, but trig ratios. All students take calculus. What's positive here? Cos theta and its bestie, secant. And it just happens because it's going to be x divided by r and they're both positive, right? So these two are negative, which they should be. Then cos should be positive, so cos theta is cooked extra rice. So we're going to get 3 over 5. And it's because x is positive that cos ends being positive. Its bestie secant is rice extra, so it's 5 over 3. And then tan theta is tan your x box, so it's negative 4 over 3. And then cotan is negative 3 over 4. Hello. We're going to talk about rotational angles now. So, all 6 of these angles, all 6 of these trig ratios, can get me the reference angle. The reference angle is this little itty bitty angle here, correct? Now, how I get the reference angle? The reference angle, you always take whatever trig ratio you want, but you have to take the positive of it. If I have a choice, I will never pick the secondary trig ratios because my calculator doesn't have those buttons. It has sine, cos, and tan. It doesn't have secant, cosecant, and cotan. We have to put those in as one over the other one. So I'm going to pick between sine, cos, or tan. If I have a choice, I'm picking cos. Why would I pick cos? It's positive already. Okay? If I picked sine or tan, it would be fine, but I'd have to take the positive out then. Because the reference angle, if you take the positive, it'll always land it in quadrant 1. And remember, quadrant 1, the angle in quadrant 1 is equal to the reference angle. So that's why we always take the positive. So if I want to do the reference angle, I'm going to look at cos theta. I should put this as dots, not equal signs. Cos theta equals 3/5. I want the angle. How do I get theta by itself? How do I get this cos to get out of my life? Yeah, cos -1. So I cos -1 both sides. I get theta equals cos -1 of 3/5. Now before you start anything, pick up your calculator. And I wish your calculator actually did this. Pick up your calculator. And I wish it did this. I wish when you went to press the cos button, it would zap you. It'd be great. It's for so many reasons. For me, it'd be fantastic. I get to watch you. But I wish it would zap you and remind you to say, what mode do I need to be in? So is everyone paying attention to me for 3 seconds here? You are right. I'll get the polynomial part of the test, and people will say, what mode do I need to be in? And I just look at you kind of like this. Because you know they say there's no dumb, it's a dumb question. Because unless you are pressing sine, everyone's listening to me because you're going to ask me this on the test. You will. I know you will. And then I'm just going to do this. A shameful sad. Unless you're pressing sine, cos, or tangent, or you're pressing second sine, second cos, or second tangent, the mode doesn't matter. You can press every other button on this calculator under the sun. You can be in degrees, you can be in radians, it will not affect it. So the only time the mode matters is if you're pressing sine, cos, or tan. So that's why I wish it buzzed you if you press sine, cos, or tan. I wish it just give you a little dap. And you'd be like, why is it that? Oh yes, the mode. Okay? So I want to go second, exactly. What do I need to make sure I'm in? Degree mode, because the question asked me for the rotational angle in degrees at the very top on the very other page. So I'm going to go to my calculator, I'm going to press mode, and I'm going to make sure I'm in degree. Okay? So, we're going to go now second cos 3 divided by 5. And now I can press the cos because I checked my degree. What is my angle? So this is your reference theta. What is my reference theta to 1 degree? 53.1 degrees. So that's my reference angle. Remember, reference angle is the bow tie angle, correct? So is that the answer to this angle where this terminating arm is? No. This terminating arm, look, it starts here and it rotates around here, until I get to this terminating arm. So it's asking me for this red angle. Does anyone have any idea how I can get this red angle if I know the reference angle is 53.1? 360 subtract that. Not 270 involved because the reference angle is this. Correct? It's that bow tie angle. So to get the red angle, I have to go theta equals 360 degrees minus 53.1 degrees. I should get 306.9 because it's be 370, but it's not. Or 307, but it's not. So that's the actual angle. So when you have a trig ratio, is everyone listening? When you have a trig ratio and I ask you for the rotational angle, you do the positive of it to get the reference angle. And if it's drawn, then you can visualize it, right? This angle I can visualize. Oh, it's this little angle in here. Oh, if I take 360 and I take that little angle off, it'll give me the red one, right? Okay. We're bypassing 3 and we're going to here. So I can give you work. I can give you work doing this exact same thing by giving you a coordinate. Giving you that coordinate made you draw it. You had an x and a y and you solved for the r, correct? That's one way I can do it. Another way I can do it is giving you the trig ratio, which will give you either x, y, or r. They'll give you 2 of the 3. And what quadrant it lands in. The reason why I have to give you the quadrant is tan is positive in 2 spots, and tan is negative in 2 spots. Sine is positive in 2 spots, and sine is negative in 2 spots, right? So if I don't give you the quadrant, you actually have 2 different places it could be. So let's look at this first one. It says, given trig ratio. So now instead of the coordinate, I'm giving you a trig ratio. But trig ratios give you x, y, or r, right? They give you 2 of the 3. And the quadrant of a particular rotational angle, find all other 3 trig ratios for this corresponding reference angle. So we'll actually get the angle as well. So let's look here. This is tan. What is the trig ratio for tan? Tan? Yeah, y over x, your x box. So did I not just indirectly give you a coordinate again? I gave you an x and a y, didn't I? So whenever I give you a tan, it's equally the same as giving you a coordinate. Or giving you a cotan, same as giving you a coordinate. Now, we're going to draw it. So, first off, I know x is 5 and y is 4. And it gave it to me in this quadrant. And I always draw my triangle with respect to the x-axis. We make the bow tie angles, right? So I know x equals 5, y equals 4. I solve for my third side. So I go r squared equals x squared plus y squared. R squared equals 25 plus 16. R squared equals 41. Square root plus or minus. And r equals root 41. It's always positive because the radius has to always be positive. We don't get a choice, right? So r equals root 41. Now I can ask you for any trig ratio I want to, and you can give it to me because we found x, y, and r. We agree? Same thing as the coordinate. So cos, what's the acronym for cos? Cook?
Extra rice.
Extra rice. So we're going to get 5 over root 41. And then what do we want to make sure we do? Rationalize, right? Rationalize means get that radical out of the denominator. So we're going to multiply by root 41 on the denominator, and then we're going to multiply by root 41 in the numerator. And so I get 5 root 41 over 41. Cosecant is friends with what? Look on your formula sheet if you don't remember. Cosecant is friends with 1 over what? 1 over sine, correct? So cosecant is sine flipped. What's the acronym for sine? Sine your resume. So this one is going to be resume your, correct? And like I said, if you don't remember, on the formula sheet it says 1 over sine. So resume is root 41, and your is 4. Done. And then sine is your resume. So it's literally that flipped. So it's 4 over root 41. Multiplied by 41, or root 41, sorry. And we get 4 root 41 over 41. Do the rotational angles after. So this one is sine what? What's your acronym for sine? Sine your resume. So to get my third side now, the third side I'm missing is x squared. Remember, if you're missing that one, it's not adding them anymore. It's, yeah, r squared minus y squared. And once you get your x and your y, then you can sketch it, right? You can draw the line. Try that out. So for this one, it's sine your resume. One of these has to be negative because the negative sign's in front, and r can't be negative. So which one has to be? Y. Now this is the catch. You have to figure out, so here it says y has to be negative. So when I go to draw my drawing, I know this one is out and this one is out. We agree? So it's either this or this. So that has narrowed it down to here or here. Now remember, cast C8. That's a lie. Try again, Lepp. Grab a mitt. Get in the game. Okay. CA, I'll say calculus, remember it's like this. So this is tan is greater than 0. What is greater than 0, fancy way of saying? Positive. So I know that those two are out now because of the negative y, right? Now tan has to be positive. Where is tan positive? 1, where all of them are positive, and 3. So it can't be here. So where am I drawing it, guys? In 3. Let's look at this one. Cook extra rice. Now sometimes they'll put the negative on the 13s, but you know better. R can't be negative, right? So you'd have to move it up to the x. But once again, this one, x has to be negative. So it can't be here or here, because x needs to be negative. We agree? Then if I do my cast, C-A-S-T, tan needs to be negative for this one. So tan is negative in this one, in S, and in C, correct? So not this one. So where's it going to be? That quadrant, right? So it narrows you down. Okay, so try these out. We're going to go through them tomorrow, and then we're going through this right away as well.